question number 2 on page 430. I'll just demonstrate this. Find the volume of the solid obtained by rotating the region bounded by the given curves. Well, our given curves are y is equal to 1 minus x squared and y is equal to 0. So let's just look at what this looks like. 1 minus x squared, you know it's an upside down parabola. You know the x-intercepts are at 1 and at negative 1. So 1, 0, negative 1, 0. And y is equal to 0, obviously, the x-axis. So we're going to take this region, and I'm just going to fill it in a little bit. So this is our region that we're using. And we're going to take this region and we're going to rotate this over the x-axis. So you know that this whole area is going to flip down. So we're going to get something that looks kind of like this, except that it's going to be three-dimensional. And there's going to be a lot of symmetry to it. In fact, it's symmetric over the x-axis. And I'm going to then take this and slice this like I'd slice a salami or something. And my slices are going to look like this. In fact, I'll do a really skinny little slice. My slices are going to look sort of like this. So there's a slice. It has a little thickness to it. Okay, there's a slice. Here's another slice. Okay, but what you're going to notice is that every single slice, I'll just draw one on the side, every single slice like this is going to be a little bit of a disc. Not exactly a disc because the sides aren't straight the way a cylinder's sides would be. But if it's thin enough, we could assume that it's going to be a little bit of a cylinder. And if it's a cylinder, well, that we can find the volume of. So what we can do is slice this into infinitely many skinny discs and add them up, take the Riemann sum. So I know that for each disc, my volume is going to be equal to, I'll try over here, volume is equal to pi times the radius squared, but my radius, as we said, goes right from the x-axis right up to the edge. So this, in fact, depending upon x's, that's my radius. So the volume for each of these discs is pi times 1 minus x squared squared. So when I go to take the total volume of this, I'm just going to add them up. So I'll take the integral of pi times 1 minus x squared squared. The thickness of each is dx. And my limits of integration are my x values. So I'm doing this for all of those x values between negative 1 and 1. So we can work this out a little bit. I think I'll do this on the next page. I have 1 minus x squared squared. Okay, so once again, so we have pi. I'm going to pull that out. We have 1 minus x squared squared dx. My limits of integration are negative 1 to 1, but I'm feeling kind of lazy, so I'm just going to go from 0 to 1 and use the symmetry. And I'm going to just multiply this out. 0 to 1. This is going to give me 1 minus 2 x squared plus x to the 4th. Of course, I could use my calculator here as well. So we have 2 pi, and the antiderivative of 1 is x. We're going to have minus 2/3 x to the 3rd. We're going to have 1/5 x to the 5th. We're looking at our limits of integration as between 0 and 1. So this is just going to give us 2 pi. If I plug in a 1, that's so easy. 1 minus 2/3 plus 1/5. If I plug in 0, I don't have to worry about that. That's just going to give me 0. So this is just going to be 2 pi. My least common denominator is 15, so that gives me 15 minus 10 plus 3 all over 15. So that is 8. So I end up with just a volume of 16 pi over 15.